thing too. Okay. Okay, so I have a string, I have two integers, and I ask the user how many years is your dog. Okay, how many years old is your dog? And I get an integer from the keyboard, and I multiply that value with 7, and I assign it to human age, and I get the name of the dog from the user again using the cin. See how similar this line 11 and 14 are. One is for integer input, the other one is string input. Okay. And after that, I print out this statement. I say that dog name is a string. Okay. Your dog's age is approximately equivalent to human age, years old human. So it is like you multiply the dog's age by 7 and it's like equivalent of human age. Let's see one simple example. How many years old is your dog? 5. What is the name? Rex. Rex's age is approximately equivalent to 35-year-old human. Okay. So this is a very simple program. It just shows you how to use a string. So what kind of string operations we have used? We have used stream insertion for a string, and we have used a cout statement. There are many other things defined on a string actually. Like I said, you could say, last time, right? You could say, okay, you could say my dog's name is Kara. Okay, or you could do stuff like my dog name is going to get dog name plus some other string. Okay, I could do that too. So assignment works, string concatenation works, many other things works. Actually, if you like to know what kind of things you can do with a string, you just go to this C++com and look at the string. There are many things that you can do with a string. Okay, let's look at these. For example, operator index operator works. Plus assignment, append to something. Okay, and append. So this is possible. You could say cout dog name dot size. When you say dog name dot size, it will print the number of characters inside the dog name. Okay, so the string knows its length. So these are much better than what we had with the character arrays. Okay, good. So we will come back to strings and we will look at them more carefully. So maybe I should mention at this stage about the string class a little bit more. Well, I keep saying that string is a new type. Also, I keep saying that it's a new class. Okay, class is like a name. Class is like a type. Okay, but classes are defined by the programmers. Okay. This string class is not part of the C++ language, but it is a part of the standard library. So somebody has written a string class for us, and we can use the variables of that class like regular variables. So in a way that we can extend the language in a natural way. When we extend the language, this new nice string class, as the customer of that class, as the user of that class, I can do many useful things like insertions and extraction from the keyboard and to the console in a very, very convenient and easy way. I can do many stuff like the concatenation or appending in a very, very easy way. or I can do comparisons. I can say if string 1 is less than string 2. Okay, very conveniently I can do this kind of comparisons. So C++ makes these kind of operations possible by letting you define new user types. Okay, and we are going to call them classes. Okay, and the classes are the main fundamentals of the object-oriented programming. So object-oriented programming in a way lets you write new types. Okay, you say that I'm going to write a new type. My type is going to be name string. Okay, if I write a new type, the variables of this new type can do assignment. Variables of this type can do the plus operation. Variables of this type can do comparisons among themselves and anything you like. Okay, so you are extending the language in a formal way, and object-oriented programming makes this possible. Once that class definition is done, as the customer of that class, as the user of that class. By the way, when I say customer is same as user. Okay, customer of a program is the user of a program. Don't think customer as a paying customer. Okay, if I am the customer of this string class now, okay, you have been customers of integer data type for the last year, okay, because you have been using them. Okay, somebody has written the integer type. Okay, they made it available for you, and you are using this integer type for the last 10 months maybe. Okay, so somebody has written this string class, and I'm now using the string class objects, string class variables as the customer, and I don't know the details of how they have implemented this string class. I don't know how this assignment works. I don't know how this stream extraction and stream insertion works. Okay, but I can use them the way I like. Okay, and you have been doing the same thing actually. When I told you, let's say I have two integers a and b. Okay, when you say, okay, I have two integers a and b, when you say let's make another integer. Okay, when you say c gets the value of a plus b, most of you did not know how this plus operator worked on integers, right? But somebody has written this. Somebody has written the plus operator for the integers as a function maybe, okay? And you have been using it without asking any questions. So they have abstracted away the details of plus operator. Okay, they have abstracted away the details of the plus operator, and most of you did not ask the question of how does this plus operator work. Okay, you did not ask this question, you took it naturally and you started using it. Okay, so in object-oriented programming languages, our main task is writing these kind of nice classes like an string class or integer class or double class. And after we are done writing those classes, the users of our classes will not know the details of how the things are done. But as a customer, they will say that I can use them in any way I like. This is easy to use. Okay, this is what's going to be our task for the whole semester, writing nice new types so that our customers can use them easily in convenient ways. By the way, when I say our customers, most of the time our customers will be ourselves too. Okay, so when you write a class, you will be the main customer. Okay, you will be the main customer. So you are doing good for yourself when you write nice classes like string and integers. Okay, good. So we will come back to this and we will talk about this more when we start talking about the classes in detail. Okay, somebody had asked this question: how about the formatting? I like to print the integers or the doubles in a formatted way and etc. So in C++, this is possible. More detail will come in chapter 10 or 12, or I don't know. Okay, so this is how you do it. If you like to see 78.50 like this when you print a double. So how do you do this in C? You say printf. I am going to print a float. Is going to be maybe 10 digits, but the formatting is after the decimal. I need 2 digits, right? And then for example, your D1. Okay, so this will print in a place of 10 characters a double. Okay, it will print a double, but it will make sure that after the decimal there are 2 digits like that. Okay, maybe I should here 1 2 3 4 5, right? 5, and there is a dollar sign there. Okay, good. This will be the same. So to do the same thing, this is what I do. Remember the cout statement? Cout, the price is and price, and we don't know what's going to come out of this statement. It could be either this one or that one. We don't know, but we like it to be 78.50. So before executing this statement, you need to execute these 3 statements. You say that, okay, I am going to modify this object. I am going to set some flags. I like my floating point output to include fixed precision instead of engineering or scientific precision. I don't want to see doubles like 10.2 E02. Okay, this is one way of printing doubles, right? I don't want to see this. This is scientific. I want it to fixed. I always like to see the point, decimal point. Doesn't matter if the double is a whole integer or not. And for the precision, I need 2. Okay. So it looks like this is more complicated and difficult to remember than the printf solution. And I agree. Okay, and I agree. But it is designed this way in C++ using the standard library input-output. We don't use printfs and scanfs in C++. Okay, so there will be more details coming in one of the chapters in the book, and I will ask you to read that chapter yourself. I am not going to go over that, or you can read it, or maybe TA will go over for half an hour. The rest you can, of course, read it. Okay, so if you have any questions about the formatting, this is as much as I will tell you about the formatting. Okay, last time we talked about cin, cout, and cerr. Okay, cerr works same as cout. And if you like to print out the error statement on the screen, don't send it to cout, send it to cerr, so that the user of your program can differentiate between them. If your program name is hello, okay, when I run hello, okay, when I do this, if I say the output of my hello should go to out.txt, and the output of the errors should go to ampersand error.txt. So these two things are different. Okay, error output and regular output is different. And of course, this line depends on your shell. Okay, I am using the bash shell. Maybe you are using TC shell, maybe C shell, maybe you are using Microsoft MS-DOS shell. It depends on your operating system, and it depends on your shell on top of your operating system. Good. Okay, that's why, I mean, this line has nothing to do with C++ programming language. This is completely about the operating system and the shell that you are using. That's why the book doesn't talk about this kind of stuff, because the book is about C++. Okay, good. Any questions? Any questions? No? Okay, I will continue then. And C in and C out, we talked about this. C in, I use stream extraction operator. Okay. This operator, it was already defined in C for left shift and right shift. Now I have overloaded it. Okay. I have overloaded it so that it has a new meaning. The old meaning is already there. Okay. The old meaning is already there. Okay. When you do C in an integer, okay, in this case it will be used as a stream extraction operator. Okay, stream extraction operator. But if you say you have an integer, let's say 64, I am going to right shift it by 2. So if you right shift 64 by 2, the result is going to be 16, right? So it will produce another integer for you. Okay, so this operator is stream extraction operator. This operator is right shift operator. So this sign, okay, greater than sign, has now two meanings. We have been using this actually. We use plus for adding integers, and we use plus for adding doubles or floats. What else? For what else we have used plus in C? We use it for addition of integers and addition of doubles. What else? Do you remember any other meanings of plus in C? Do you have? Okay, and this time use your microphone again. I use plus for integer addition. I use plus for double or float addition. Maybe I could say this too. Maybe I could say plus 7. B gets the value of plus 7. Yeah, I mean, like a unary plus. Yeah, this is about integers too. Doesn't make any difference between B gets the value of 7 or plus 7. It's the same thing. But there was one other use that we have used, that we have employed for the plus operator in C.
Plus plus?
Plus plus is a different operator. It is not a plus operator. Plus plus is a different operator. Okay? Plus and plus plus related, but they are different operators.
Show index pointer.
Say that again, Muhammad.
Show the index in pointer.
In pointers, right? Yeah. Well, let's say I have an integer pointer p. Okay, I have an integer pointer p, and its value is something. I don't know. This is a valid statement, right? On the left side of the plus, I have a pointer. and on the right there is an integer. So what does this mean? Starting from the position of P, okay, advance this pointer 7 integer length. Okay, 7 integer length. So plus had many different meanings. They are overloaded. And this stream extraction and insertion operators are again overloaded with left and right shift operators. And we will do the same thing. Remember what was our task in C++ or in object-oriented languages? Writing new classes, easy to use classes, right? When you write new classes, I like them to have these kind of operators defined. They did it for string class. They did it for the string class. Okay, for the string class they defined this plus operator, and they defined this. Okay, for a string str plus a b c verbs. Okay, and this one works too. Str plus assignment def. This one works too. They have overloaded that one too. Okay, and they have overloaded str7 index operator. Okay, they have overloaded this one too. So many operators are overloaded, and we are gonna do the same thing with our classes. When we write a new class, we are gonna do the same thing. For example, I will make you write this new hex game, your homework, using object-oriented techniques, and you are gonna write a new class that represents the hex board, the board itself. Okay, and there will be some operators defined on that board. Okay, so hex board is going to be a new class, and you will make new objects of hex board. And how you design it, it will kind of depend on you, and I will guide you a little bit, and I will leave the rest to you. Okay. So as we did in C, before we execute a scanf statement, we usually print out a statement using printf. Cout, enter the number of dragons, and then cin. Without doing the cout first, writing the cin doesn't make much sense for the end user, because the end user would not know if the computer is waiting for our input. Okay, program style is very important. Definitely, okay, definitely you are gonna use indentation. Without indentation, your programs will not be readable. You cannot read them. Indentation is again for you. And again, for the comments, in your homeworks, we need comments so that we can understand what you are doing. Comments are for you. Comments are for your teammates. If you are developing a project with a number of people, okay, for the other people to be able to understand your code, okay, you need comments. In C++, we have two types of comments. This type, using slash, star, and star slash, okay, everything in between those two signs will be ignored by the compiler. Okay, but the first type is slash slash. Okay, when you put slash slash for that line, everything that the compiler sees after the slash slash for that line will be ignored. Okay, we use these very often. Sometimes we use this, and sometimes we use this. If the comment is a single line, then we use the first one. If the comment is multiple line, then we use this line. Okay, both methods are commonly used. Did we have any comments in our previous examples? Yeah, okay, here we are using this one. A single line comment. Okay, comments are very important. Always write your comments in your programs. And so what is the best time to write your comments? It is as early as possible. Okay, some people write their code first. After writing the code, they go back and write the comments. This is not correct. This is wrong. Okay, so you should write your comments while you are writing the code, or before writing the code, actually. Okay. Before writing your function, you will say that this function is going to do this and this and this and this. Because if you try to express whatever you are going to do with that function in Turkish or in English, sometimes it makes more sense to you, and sometimes you realize your mistakes. You will say, oh, there is a logical error. This cannot happen, because you are trying to express whatever you do in Turkish or in English. Sometimes, and I'm sure this is happening for most of you, when you write a function, sometimes you will have difficulty explaining the function of that function in English and in Turkish. Okay? You will not have any words. You cannot say anything about it because it is so complicated, or it is doing so many things. That means that you are not writing a good function. Okay, that's not a good function. If you are writing a good function, okay, if you are writing a good function, nice function, then the Turkish or English comments, definition of that function should be simple enough or easily explainable. This is a very nice function, cosine double. How do you explain this function to somebody? A customer? You will say that this function will take a double. Okay, it will calculate the cosine of that double and it will return the result. That's it, right? So a single line or two lines. And I said everything about this function. Okay, and I said everything about this function. Or what else? A to I. Okay, A to I will take a constant character pointer and it will convert the string representation of a decimal number to an integer and return an integer if it can. Otherwise, it will report an error, etc. Okay, so it will be easily explainable. If you are having difficulty expressing your function in Turkish or in English, then your function is not a good function. Probably it is trying to do many things at the same time, and probably it is doing unrelated things at the same time. It is doing this and this and this, and it is doing that too. And sometimes it is not doing that, etc. Okay, so that's not a good function if you are in that position. Okay, and identify name, we talked about it, and we are going to use this naming convention, lower to upper, for the variables, and important is meaningful names. Okay, libraries like in C++, in C we have libraries in C++, many libraries. We have seen two of them now. One of them is IOStream, the other one is string, and we are going to see some of them later. Okay, and if you are going to use a library, you need to include the header file for that library. Okay, we use the IO library of C++, and for that one we included IOStream. We've used the string type, string class. For that one we included string. Okay, we included string. I am sure you have noticed this in C. If you write a function, if you write a program, just a program, main program like this, okay, main program printf A, B, C, and return 0. Okay, why didn't it work? Okay, return 0, and that's it. So total of 1, 2, 3, 4 lines. Line number 1, 2, 3, 4 lines. Would this program compile in C? Would this program compile and run in C? Question.
It should.
But I did not include the necessary header files for the printf. What kind of printf is this? Printf. Okay. Well, there are more than 100 people in this class, and I am sure at least half of you had written programs like this, forgetting about the include preprocessor directive, and you have realized that without the include in C, it still compiles and runs. Mohammed Sefa, did you try this? In C, this will compile and run. Yes, because in C you don't have to use declarations of your function that you are calling. Okay, if the compiler sees a function like this and it says that I have never seen a function like this before, so what am I gonna do is I will assume that this function returns an integer, and I will turn off type checking for the input parameters. Okay, most of you did not realize it. Most of you had written programs like this. You forgot to include you forgot to include the stdio. Okay, but it worked. Maybe you did not realize that you forgot it. Okay, so in C it is possible to write a program. This is not a nice way of doing it, but it works. In C++, if it's a C++ language, this will not work, because C++ program will say that I have never seen a printf before. What is printf? Because I did not include it. Okay. So Gebze says that I tried using string without including string library in C++ and it worked. Gebze, it worked because, do you know the answer for Gebze? It should not work, but it worked for Gebze. Does anybody know how it can work? He says that without including the string header file, it worked. How could that happen? Probably what he did was like this one. Okay, he took this out, and this will probably compile. If I raise line number 3, this will probably compile. Why? Okay, let me give you a hint. This will not compile if I erase both of them. If I erase both of them, this will not compile, but if I erase only line number 3, this will compile. Why? Because in IOStream, it needs a string header file. Inside the IOStream, it includes the string itself. Okay? That's why it will work. But if you don't include anything, this will give you a compiler error. Okay? Just go to IOStream header, and you will see that it includes the string itself. Okay, that's why at the beginning of the header files we write the gauge, right? If defined, okay, if not defined, then define this, etc., right? Because at the end I may end up including the same header file more than once in the same compilation unit. Okay, good. So, and then we have this namespaces. We kept ignoring them. Well, we are gonna kind of ignore them anyway until we will see the namespaces chapter in our book. But for now, this is how the book defines it. Namespaces are defined as collection of name definitions. Okay, we have a namespace std, standard namespace. Inside std, okay, namespace std. Inside this std, I have my cout, cin, cerr objects. I have my string class, and I have many standard classes and objects, many of them. So they are collection of name definitions. They are all defined inside this namespace. In C, we don't have anything like this, a namespace, but in C++ we have it, because sometimes, what did I say? I said that string is not part of C++ language. It is a part of the standard library. It is part of the standard namespace. If I don't want to use the standard namespace, okay, and if I don't need it, I may say that, okay, I will have my own namespace. Let's say my namespace is Gebze Technical Institute namespace. And inside my namespace, I will have my cout object. And I will have my string class. Okay? And this would be possible with the namespaces. So std is not the only namespace that I have to use. I may have many namespaces available, and I can write my own namespaces. But for now, we are going to use the standard namespace. And to be able to use it, this is what we do. At the beginning of the program, I will include my IO stream. That's the header file. And I am saying that I am going to use some names from this standard namespace, such as cout, cnn, etc. If you don't want to do this, this means that I am going to use everything. If you're going to use only cin and cout inside this from this standard namespace, then you could specify them like this. I will use cin and cout. Out of all the hundreds of name definitions inside std, I will use only two, cin and cout. This is what I mean by these two statements. And if you like, you could do this that way. Anyway, this is just an introduction to namespaces. We are gonna get it. Okay. Okay. So Gökbey tried whatever I said and tried using string without including. Okay. So good. Always do these kind of experiments. Okay. When I tell you something, usually it is correct. Okay. And if you try to verify what I am telling you, you are going to run into situations like Gökbey has defined it. And he said that I erase string and it doesn't work. What are you talking about? What you are saying is not correct. I mean, whatever I say, if it turns out to be not correct, it is probably your fault because I am supposed to know better than you. It is probably your fault that there should be something else that you are missing, or maybe I missed to tell you. Okay, it's either a compiler switch problem, or what else, or maybe like there is another include and it is including string and etc. These kind of things, okay, will make you learn even more about these kind of situations, these kind of language features, okay? And these will be valuable later, okay? So if you know something, try to verify it with the compiler. If there is a problem, if the compiler doesn't work the way that you are supposed to, that you think that it should work, then try to understand what's going on, even the error messages. Why am I getting this error message instead of that error message? This is a very good way of learning stuff. Okay, so we are done with chapter number 1. We kind of went very slow with the chapter number 1. So we will be very fast with chapter number 2, 3, 4 until 5. And after that, we are going to get slower and we are going to go into details of object-oriented programming. So I told you a few important things today about object-oriented programming languages. Object-oriented programming languages. We try to write new classes or new, you may think this as, for now, types. Okay? We are going to write new classes, but these classes will not be ordinary classes. They will be easy to use classes so that our classes are reusable. So we are trying to do reusable programming with the object-oriented programming languages. Why? Because writing code is difficult. You have to design it, okay? You have to implement it, you have to test it, you have to find all the bugs. Once you are writing some piece of code, once you are done writing some piece of code, you want to reuse that code over and over again, because you know that you can trust that code now, right? It is free of bugs, or it is almost bug free. It works very nicely and efficiently. Okay, so object-oriented programming languages, okay, makes it easy for you to write such code, reusable code. That's what we are after. Okay, we are not using object-oriented programming language just because they are popular, everybody knows it, we can find jobs and we can do projects, etc. No, we are doing object-oriented programming because if you apply the rules of object-oriented programming languages correctly, okay, your final code will be reusable code. For a project, if you write code, at the end, that code will be useful for some other projects too. Okay, how are they going to be useful? Because you are going to write classes, right? Like the string class. Okay, that's the only example that I can show you. Okay, right now. So we are after writing reusable code and writing new types. Reusable types is the best way known to write reusable code. Okay, let's take 10 minutes of break. After the break, I will start and I will take questions from you. So it is 11:22 right now. Let's be here around 11:32. 10 minutes of break. Okay, people. Let's start. Chapter number 2, flow of control. We will, in this chapter, there is nothing much new about C++. It is all about C. We will see a few differences between C and C++.
Sir, your microphone is mute.
Okay, sorry. So let's start chapter number 2. Chapter number 2 is about flow of control, and it is very similar to the flow of control is very similar between these two languages, C and C++, and I will try to point out small differences. We will look at these Boolean expressions because this type new bool is new. This new type bool, we need to pay a little bit attention. Branching mechanism is exactly the same. Loops are exactly the same. And the way how we do the file input output is a little bit different. We don't use fread, fwrite, fopen kind of functions. Okay, maybe you noticed, maybe you did not. We did not use any functions so far in our C programs. Okay, all we had used was operators, right? We use cout, stream insertion, cin, stream extraction. What else? We used a string class, and if I have a string, maybe I use an assignment operator and etc. I did not call any functions like printf or scanf or fopen or fwrite, etc. Because in object-oriented programming languages, we don't like global functions. Global functions, we don't like them. Okay, you may say that the function main is a global function. Yeah, that's true. That's why some people don't like C++ as an object-oriented programming language, because C++ is trying to be both a C kind of imperative programming language, also an object-oriented programming language. We'll talk about this kind of stuff. Okay, so when we come to file input output, you will see how we can do opening a file, writing to a file, reading from a file without using global functions. Okay, so first, before the object-oriented programming languages, OOPL, there was, and there still is, structured programming. Structured programming says that any program structurally can be written and should be written this way. You have your statements, one statement after the other statement, okay? So I'm gonna follow these green stuff, okay? Using these three main building blocks, you may write any program you like. You can write statements one after other. You can say that, okay, you can say that here, cout, enter something, then cin dot, then some expression. Okay, do that kind of stuff. So I have 1, 2, 3, 4 statements one after the other. Okay, the statements can follow each other. This is one thing. Okay, this is just a sequence. Or you could do this kind of branching mechanism, condition mechanism, branching mechanism. There is an if statement. Okay, there is an if statement. Let's say if A is same as B, then assign A this value, otherwise assign B this value. Okay, this is just one example. Or you could have your statements like this. You can have your statements one after the other. So I will execute this one, and this one in sequence. Or you can put a condition, and if the condition is true, I will execute this one. If false, I will execute this one. Either one of them. Okay, this is the second building block. The third one is loop structure. Loop structure says that keep doing the statement until this condition is false. If the condition is true, okay, keep doing this statement in a loop. Okay, and we did this while a is less than 7, maybe increment a, something like that. Okay, so structured programming says that any program can be written by combinations of these three rules. Okay, any program can be written by the combination of these rules. If I do this, okay, 1, 2, 3 statements together, and I can block them into a single statement, and I can put these 3 statements inside the statement position here or there or there. Okay, so or I can take this statement and I could use this instead of this statement, or I could use this statement instead of this statement, right? So combination of these statements is possible too. If you write your programs this way, you are writing your programs in a structured way, and you will end up producing very nice code. What do you mean by very nice code? Your code will be maintainable, will be reusable. Okay, why it is going to be reusable? Because it is structured. So what does this structured program not include? It does not include any go-to statements. Okay, go-to statements are considered harmful, and people have realized this in 1960s. At the end of 1960s, they said that let's not use any go-to statements. So all we do is sequence statement, condition statement if else, or the looping statements, or any combinations of these. Go-tos are bad. Why? Because let's say I did this block, there are many statements in it, and I do this block, there are many statements in it. Okay, if I start using go-to will do this, and from here to here, maybe another block there, and from here to there. So these 3 blocks are kind of mixed together. I cannot remove the center one and replace with something else, because there are so many go-tos are connecting this. I mean, this block is source of the many go-tos and destination of many go-tos. But if I do this in a structured way, if I don't have any go-to statements in it, okay, this one has lots of go-to statements, but if I do it this way, no go-to statements in it, okay, so nicely I can take this block out and replace it with some other, let's say a loop structure or condition structure, whatever. Okay, so these are the few rules for the structured programming language, and the C programming language, okay, follows these rules. It says that, okay, whatever I give you, it will be either a sequence of statements, if condition or for condition, etc. Yes, I know in C there is go-to statement available, but usually people are not encouraged to use that go-to statement. They are discouraged to use go-to statement in C. So why is it available? Why there is a go-to statement in C? Just in case, because not all the programs written in C are written by the human beings. Sometimes I may write programs that produce C programs, okay? And those produced C programs might include go-to statements, okay? So go-to statements are bad for the humans, but that they might be good for the machine, because in the assembly language, in the machine code, there has to be go-to, right? Branching. So structured programming before the object-oriented programming languages was there, and C uses structured programming. When we teach you C programming language, we follow the structured programming rules. Object-oriented programming says that, okay, this is nice. I am going to follow the structured programming rules, but on top of it, I will introduce you a number of rules for the object-oriented programming. You're going to write classes. You're going to abstract away the details of the classes, okay? And you're going to make your interfaces so easy to understand and use so that your classes are usable. So I will list you a number of rules like this. Once you follow those rules, you at the end you will write nice object-oriented programming examples. Okay, good. So let's go to beginning again. Remember, first we are going to do the Boolean expressions. Boolean expressions. Okay, there are operators for the Booleans. That is and or. Also we have binary operator not. Okay, binary operator not. And what else? Do you know any other Boolean operators other than and, or, and not? Do you know any other binary, any other logical operators? These are logical operators. This and this and that. So Enis, you know another logical operator. Is that what you're saying? Yes? So Enis, tell me what you know then. Use your microphone. Just turn on your microphone. Why are we waiting for you? What is, okay, exclusive or Barish? So what is the operator for exclusive or? What is the operator for exclusive or? Okay, this is exclusive or for the binary, and this is exclusive or for the logical. Okay. So these are the logical operators. Don't confuse logical operators with the binary operators. Logical operators work on the Booleans. Okay. Binary operators work on the integers, binary numbers. Okay, we have a new data type bool. This bool, if you say I have a Boolean A and B, okay, A could be true, B could be false. With this new type, okay, it's a new type, C++ type, it's not a standard library thing, okay. There are not many things that you can do. The things that you can do with these variables of this type are assignment, of course. I can do the assignment, or I could do AND operation, or I could do OR operation, or I could do NOT operation, right? And there is not much I can do with these types. They are still very useful. They are still very useful. For the integers, if I have integers, C and D, much more things that I can do. Many more things that I can do, like plus, minus, division, multiplication, assignment again, and with the integers again, left shift, right shift. There are many operators defined on integers. Again, the bool is a new nice type. Integer is a new, it's not a new, but it's a nice type. And its interface is very nice to understand, very easy to understand. They are nicely written classes, you may think. Okay, good. So these are some truth tables for the or and not. And like I said, the operators defined for Booleans. There are many operators defined in C++. Let's look at them in the order of precedence. These are the highest priority operators. This is the highest one. We did not see this yet. No, we have seen it. We said that at the beginning of the, okay. Remember our C++ programs? When we say include IO stream, and then We said that using namespace std, we don't have to do that actually. You could do things like main, okay, std scope resolution operator out. Hello. You could do this without using any using statements, okay. You could do definitely directly inside the std namespace. There is an object named out. I'm going to use that object now. I did not say any using statement, okay. So this is the scope resolution operator, and it has the highest precedence. And after that, okay, I have these operators: dot operator, member selection operator, array indexing, function call operator, postfix increment, and postfix decrement operators. Okay, so the precedence of these operators are the same. Okay, when we use the dot, remember the dot operator, we use the dot operator to access the members of a structure, right? Let's say I have this struct A, and inside that there is a field. This is how you access the struct. How about this one? Pointer. I have a struct pointer, str, ptr, and I use this to access the field. An array indexing is another operator. Let's say I have an array in the array, integer array. I like to access the 7th element of this array. Or function call operator. Function call is an operator. I have a function named f. I am calling this function with the parameters 7 and b. Okay, this is an operator. And the postfix increment and postfix decrement operators. Okay, so the presence of these operators are higher than the presence of these operators. And if I do things like and the associativity for these operators is from left to right. This is the associativity. Okay, from left to right. If I do things like okay, it's from left to right. If I say there is a structure A, inside that there is another structure B, inside that there is a field 1. So this one is done first, then this one. Okay, so because it's from left to right. So since the presence of this one and this one is same, so how are we going to decide which one is going to be done first? This one is going to be done first, then this one is going to be done next. Okay, good. And then we have the other operators like these are the postfix. Okay, A plus plus has a higher presence than plus 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 A prefix. Okay, so others like not operator, unary minus, unary plus, dereference operator, address of operator, new. Okay, you don't know about these actually, these three. These are some new operators. We will see them later. And there's the size of operator and the typecast operator. Okay, after these, I have multiplication, division, and remainder operators. Presence, then I have abstraction, subtraction, and then I have insertion, extraction, or left shift, right shift operators. Then after that, comparison operators. Okay, comparison operators, and other equal, not equal comparison operators, logical operators, and comes before or, and then I have assignment operators. And after that, I have the conditional operator. We don't know what this is yet. We will see it at the end of the semester. Then I have my comma operator. Where do we use the comma operator? Does anybody know where we use the comma operator? We are using comma operator a lot, but it has a very low presence operator. It's the lowest. 2 questions. Where do we use the comma operators? What does it do? Separating? No. Atakan, that's a good point, but No, when you say F1, 2, 3, these are commas, but these are not comma operators. Enis Yalçın, no, that's not it. No. Again, when you say int A, B, C, these commas are not comma operators. We are using comma operator somewhere, and we use it so often. Kadir, I don't know. I think you are writing int I, comma j. No, people said that already. No, that's not it. You are correct that these are commas, but these commas are out of the grammar of the C language. It's not a comma operator. Object separation, I don't know what object separation is. In arrays, where do you use dervish in arrays? Where do you use comma in arrays? No. So maybe I start from the other side. The second question, what does the comma operator do? No. Hussein, what you are saying is same as F1, comma 2, comma 3. Object, I don't know what object sequence is. Nobody knows what object is, Berkan. No, it is not. So, what does comma operator do? Does anybody know what the comma operator does? Everybody knows. Okay, when you say an operator is like a plus operator, very famous operator, everybody knows it. It takes two parameters A and B, okay? It adds them and it returns the result, right? Operators usually work that way. When you do A, B, okay, this will take two parameters. This will take the value of B and it will assign it to A, right? To A. So what does the comma operator do? Comma operator does this. It will evaluate its left-hand side, then it will evaluate its right-hand side. So it takes two parameters again. It will evaluate its own left side, then it will evaluate on its right side, and it will return whatever the right side returns. So this whole thing will return, when I say cout, this statement, at the end of this statement, the value of A will be 2. Let me make this 4 so that it is clear. Okay, the value of A will be 4, value of B will be 2, and on screen I will see a value of 2. Why? Because this assignment will return a 2. Okay, so it looks like it's a very stupid operator. Why would I do such a thing? Okay, if I like to assign A4 and B2, then you use two different statements. But in for loops, usually we do this. Remember the for loops? We say that I starts from 2, then this is my condition, then I will increment the value of I. We would do this, right? But sometimes I need to initialize two things. In that case, I would say I is 2 and j is 3. Okay, and for each loop iteration, I like you to increment both I and j. Okay, in this case, I use this comma operator and comma operator. This comma operator will execute this one first, then it will execute this one. It will execute this one first, and it will execute that one. Okay, so in for loops, we have been using the comma operator without knowing that we are using the comma operator. And the comma operator is a very, very low priority, low precedence. Okay, precedence. All the operators, okay, they take either, okay, binary scope resolution operator is a binary operator. it takes 2 parameters. All of them here, okay, dot operator, okay, it's a 2 parameters. How about the index operator? How many parameters does the index operator take? How many parameters does the index operator take? Atakan, one integer? No. Well, I mean, you're talking about the, yeah, and this is correct. This is 2. Why? Because how do you use an index operator? Array 7. Operator number, the parameter number 1 and parameter number 2. Okay, it takes 2 parameters. How about the function call? How many parameters does a function call take? It will take as much as you like. Okay, it will take up to from 0 to n. So this is the only operator that takes unlimited number of parameters. We know that these are binary operators. Most of them are binary operators. Okay, and there is a special operator at the end. It is the conditional operator. This one will take 3 parameters. Okay, other than the function call, this is an exception. Okay, all the operators, they take either 1 parameter, 2 parameter, 3 parameters, or in case of function parameters, many parameters. But this is the only one that take only 3 parameters. So how does it work? We already know how it works, and we are going to see some examples of it. Okay. So somebody has a question. Why are the other users not considered operators, but not one is? Why are the other users not considered operators, but I did not understand your question, Emirhan. Use your microphone to ask your question.
When you were asked about the comma operator, we listed a couple users, but you said they were not operators.
Those are not operators. No, these are not operators. I mean, this comma is not an operator. This is not an operator. That's the definition of the syntax, actually. Okay, that's the definition of the syntax. I never said that when you do integer main something like that. These curly brackets, these are not operators. This is a part of the syntax. Okay, part of the syntax. Also, this parentheses, this is not a function call operator. It's part of the syntax. Okay, so the syntax is defined that way by the language designers, and inside the syntax they say that, okay, you have a number of statements, and inside the statements you may call operators. When you do the for statement, inside the for statement there should be 3 statements, 1, 2, 3, and for each statement there could be operators. Okay, that's the definition of the language. You cannot ask those kind of questions. Why are you doing this and that and that? We may come up with some explanations, but usually it comes to a point where they say that, okay, it is designed this way. That's their definition. That's their design. Okay. In Turkish there are some structures we use it that way. In Turkish I say ben okula gidiyorum. Right? So it is subject, object, verb, right? Turkish is designed as subject, object, verb language, but in English I say I am going to school. So English is subject, verb, object. So you don't ask why is Turkish subject, object, verb, and English is subject, verb, object. You cannot ask those kind of questions. The language is evolved that way. So why they design their, I mean, maybe instead of using comma to separate these arguments, they could have used, I don't know what didn't, maybe they could have used, okay, column, right? So it would be easy for us to differentiate between the separator between the parameters of a function call and the comma operator, but they did not, so they used the same thing. Okay, but they did not. Because maybe writing the column is repeating that key is not that easy. I don't know. We don't know. It comes to the same thing again. Why Turkish is that way and English is that way? We don't know. We just use them. Okay. Good. Okay. So this is a table. Of course, I am not expecting you or anybody to memorize all the associativity and well, it is easy to learn the associativity, but the presence is kind of, it is not that easy to remember. But usually you do things like, when you say A gets the value of B times 7 plus 2, I know that first this one is going to be done. This is the highest precedence. Then the plus, then the assignment. Don't do this. Okay? This one definitely says that do the multiplication first, then add 2, then assign it to A, right? Don't do that. Why? Because I know that the precedence of A is the smallest. Precedence of the assignment is the smallest. I know that. Assignment is going to be done last. I know that. Okay? Okay, before the assignment, I know that plus is going to be done. And before that, B times 7 is going to be done. Usually we draw parse trees for these kind of cases. Let me try to draw this one here. We say that, okay, we have a parse tree. We say that assignment operator, it takes two parameters, A, and on the left it is A. On the right, well, there is a plus operator. On the right of it there is 2, but on the left of it there is this one and B and 7. To be able to execute this assignment operator, you need the left-hand operator. This is the L value, that's right. But for the R value, I need to do some addition. But for the addition, I have one of the parameters available. The other one has to be calculated. Okay? The other one has to be calculated. This is how the compiler sees this expression. So write it that way, and you know that it's going to work the way. Don't use extra parentheses if it is not needed. Okay, good. What can I say about these operators again? Yeah, this comma operator and conditional operator are kind of special. Okay, they say that this comma operator, let me give one example for the comma operator, says that I guess this value of 7 and B guess the, let's say J guess the value of 71. Okay, I know that this one is going to be done first, then this one is going to be done. How about the conditional operator? Conditional operator, let's say if A is equal to B, then assign 7 to A, and otherwise assign 9 to B. Okay, this is a ternary conditional operator. These two operators say that I will do this one first and this one second, definitely. There is no exception. This one says that I will do this one first, definitely. Depending on the results, maybe this one or this one. Okay, so these are the operators that define the order of execution. No other operator defines the order of execution. No other operator defines the order of execution. What do I mean by this? Let me give you this example. Get rid of this one. Okay, so how about this? A times B plus C times D. So there are three operators. Which one is going to be done first? A times B or C times D? Everybody, question. Which one is going to be done first, A times B or C times D?
A times B.
That's the wrong answer. No wrong answer. A times B is the wrong answer, and the correct answer is not C times D. The correct answer is B don't know, okay? Because the parse tree is like this, plus A, B, C, D, okay? I know that before plus, these two has to be done. Okay, before plus, A times B and C times D has to be done. Otherwise, plus cannot happen, right? But plus does not say anything about which side is going to be done first, A times B or C times D. Okay, so that's a trick. That's a problem. Why? Because if I am doing things like this, A gets the value of 7 and A, this is A, and this is an assignment A and 7. Since plus does not tell me which side is going to be done first, I don't know if A is going to be assigned a value of 7 first, then this multiplication operator. If this multiplication is done first, then I will take the original A value. If this multiplication is done first, then I will take the value of 7 for the A. Okay? So that's why they say that don't use these kind of expressions. This is dangerous. Okay? Because you don't know which side of the expression will be evaluated first. So you may think that, okay, I know that, I mean, this is a left to right, right? I mean, there is a associativity rule. Associativity rule says that it is left to right. First this is going to be done, then this is going to be done. Associativity rule applies only these kind of cases. Only these kind of cases. When you do A times B times C, definitely this one is going to be done first, and then this. But I am not talking about a case like that. I mean, this expression is different than this. There is a plus in between, right? Okay, so the exception to this rule, the execution order is the conditional operator and the comma operator. Comma operator says that this one is going to be done first, and this one is going to be done next. How about this? How about this question? Comma K gets the value of 5. So how would you draw the parse tree for this statement? How would you draw the parse tree for this statement? Well, at the top it has to be a comma, right? On the left and on the right. What is the associativity for the comma operator? Left to right again. So comma on the left and on the right. The associativity is from left to right. That means that this one is going to be done first, and then this, right? So this one has to be this. So I would say there is a comma here, and with this comma operator, say that I will do an assignment, and assignment is K and 5. How about this part? This part say that there is a oh, I think I did this extra. This is not correct. Let me do it this way. Move it a little bit up. Okay, and the second comma says that I have a comma and This comma says that assignment operator I7 and J71. This makes sure that this comma operator makes sure that this side is done first, and this one says that this side is done first. First assign 7 to I, then 71 to J, and 5 to K. The situation becomes more clear if I do this. I know that the value of at the end of this execution, the value of I will be 7, value of J will be 71, and the value of K will be 7 again. Okay, so these are not related to, actually these are not parts of the C++ language, but they come from the C language, and you need to be careful about this. The main idea out of all of this discussion is don't use statements like these, because these statements might evaluate to different things at different times, depending on the compiler options, the compiler type, operating system type, etc. Usually it depends on the compiler, how the compiler is implemented. Only the comma operator and the Turner conditional operator specify these kind of execution order. The rest, they don't. Okay, good. There are some precedence examples. Okay, in this case, I know that plus has the highest priority precedence. Plus is going to be done first, and then these comparisons, and then the OR operation, logical operation. Okay, there is this short circuit idea. You know what short circuit is? Did they talk to you about this? Short circuit says this: the AND operator actually is a special operator. It also says that I will evaluate this side first. It specified the order of the execution. I will evaluate this side first. If it is true, if it is true, I will evaluate the other side. If it is false, I will not evaluate this side. Okay. So the AND operator, also the OR operator, logical AND and logical OR, they do the short circuit evaluation. I will evaluate this one first. If it is true, I will evaluate this one. For the OR operator, I will evaluate this one first. If it is false, I will evaluate the next one. Okay, so it is doing short circuit. That's why this is very dangerous. Why? Because the value of y sometimes will be incremented, sometimes will not be incremented. The value of y will be incremented if x is greater than 1. Okay? Otherwise, it will not be incremented because of the short circuit behavior. Okay? In C++, we don't like these kind of statements, if 1. Okay? If you like to do this if true, because we have a new type named Boolean. Good. Okay. In C++ 11, they have introduced a new enumeration type. We had a similar type in C2. Okay. In C++. This enumeration type is this. You say that I have a new type named days. Days can have values like Sunday, Monday, Tuesday, Wednesday, Thursday, etc. Okay. I have also a new type called weather, and this weather can take 2 values only, rain and sunny. Okay. Here I have a variable named D. Type of D is days, and the value of D is Tuesday, days 2. Okay, this is called enumeration, strong enumeration. And in C we had a similar structure like this, but in that one we used to use integers to represent Sunday, Monday, Tuesday. These are not integers. Okay, these are just correct, proper values from the enumeration. We use this kind of stuff to make our programs more clear. In C, we used to use, like, as I said before, integers 0, 1, 2, 3 to represent Sunday, Monday, Tuesday. Now with the enumeration class, we don't have to. We use their proper names. And by the way, I don't say days D is assigned the value of Tuesday. I say days D is assigned the value Tuesday inside this days class. Okay? And I do the comparison that way. Just notice this declaration here, this one. It is very similar to our popular declaration. Integer a is initialized with the value of 12. I say that I have a variable, its name is a, its type is integer, its initial value will be 12. I have a variable named d, its type will be days, and its initial value will be days Tuesday. Okay? With this a, I can do many things like incrementing, decrementing, assignment, comparison, plus, minus, etc. With this d, I cannot do much. The only thing that I can do with is another assignment or comparison. There is no plus or minus or increment, decrement is available for d. Brock has a question. Can we use using namespace days for this example? No, Brock, because days is not a namespace. Days is a new type, new class. Using statements are used with the namespaces. Okay. Okay, so keep this in mind, and we are going to use this in some places. Branching mechanism is the same as in C. No problem. There is a if statement. If it is true, then I will do this. Otherwise, I will do this. Well, it's an important mechanism, but you have spent maybe a week, maybe more than weeks, more than 1 week to learn about if statements and else's. I'm not going to talk about it, but it's the same. Assignment operator versus the comparison operator, they are two different things. Okay. You see the error here? This will compile and run, right? This code will compile and run. This is a very bad code. Why? It says that I am assigning 12 to x. Since 12 is different from 0, it will do something. It will not jump to here. So it looks like somebody is trying to do comparison operator, but they forgot the second equal sign. They are running into this problem. Okay, so don't do this. Don't do this. Some people, to avoid these kind of cases, some people do this. They do if 12 or, okay, if 12 x. They do it this way. If you do it, and if you forget one of the equal signs, the compiler will give you an error message. Why? Because 12 is not an L value, right? So if you make it a habit to write your if statements like these, then you will if you have this question, you will get help from the compiler. Okay, before I forget, I need to take attendance. So how many people do I have? I have 100 people. And I am downloading my attendance list. Did it work? Let me see if it worked. So stupid, it doesn't tell me anything about if it worked or not. I guess it worked, yeah. Okay, I got it. Okay, any questions so far? Any questions? Okay, so tomorrow I will continue in the morning. I will finish up with this chapter. I will start a new chapter. If there are no questions, that's it for today. Thank you.